Hi everyone, and welcome to our first lesson in online instruction for 13 MCal. I hope everyone is doing all right and has enjoyed a little bit of this time off so far. We are going to stick to the same format that has been outlined by the school, which will be 2 lessons a week. The last lesson that we did was the u-substitution lesson on the Monday that we left. So we are going to do 2 lessons this week, even though it is a short week. We need to get caught up as quickly as possible, but we don't want to overwhelm you. So, first of all, if you have not done the u-substitution homework that I assigned the last day of school before we went home for the lockdown, you need to stop this video and go do that homework first. I have posted on the classroom a link. I have posted the notes, and I have posted a link to my YouTube video that walks through the process of this. So if you don't remember how to do it and you would like a refresher, you can go watch that video. Remember, you only watch part of it because the whole thing goes through pretty much everything we're doing for the next week or so. So only watch up to the first 17.5 minutes and then do that assignment, do some of those problems before trying to attempt this lesson. Now, if you already did the u-substitution work or you've done some of the problems, you should be ready for today's lesson. Today we're going to be using the u-substitution method to integrate exponential functions, which are the e to the x type problems. But before we dive in, we are going to first do a review question on u-substitution. So let's do the integral of 8x minus 4 to the third power dx. So right now I'd like you to pause your video, attempt this problem, see if you can get an answer, and then turn it back on, and I will work through it step by step just to make sure you remember the steps in the process of u-substitution, but because those steps are critical for the lesson that we're doing today. So go ahead and pause it now. All right, we are back. Let's see if you got your problem correct. First thing we have to do in this process is identify u. Now remember that u is the inner function. This is a problem that looked like chain rule initially. So we look for the function that is on the inside, which in this case is 8x minus 4. Then we take the derivative of that, which we call du. The derivative of that is 8 with a dx on this side as well. So as you notice in our problem, we do not have the 8. So we need to insert it. So we come back to the original problem. We insert the 8 inside the integral. And to balance it out, we put a 1 over 8 on the outside of the integral. The next step is to change the entire integral to u's. The 1/8 is already a u term, so we leave it there. We write the integral symbol, and we notice that 8 and dx together make the du. So there is our du. Now we look at what's left. What's left is what we called u raised to the power of 3. So we change that to u to the third power. And now our integral has transformed from an integral in terms of x, to a u integral. Now the next step is to go ahead and integrate this, to use the power rule to take this thing out of the integral symbol. So the integral of this will be the 1/8 on the outside. Draw your bracket, write your u, and remember, does the power of u go up or down? Remember that integrals increase in power, so this becomes a 4. In the bracket goes 1 over 4, and then don't forget what on the end? Your plus c. Okay, is this problem finished? The answer is no. We must change it back to x's. So as we do, we're going to go ahead and combine our terms. This will be 1 over 32, bracket 8x minus 4 to the 4th power plus c. A lot of times in the book, they will write the answer this way. They will write 8x minus 4 to the 4th over 32 plus c. That is the same answer. All right, so if you feel confident with this method, you are ready to move on to the next problem. So now we're going to be talking about integrating exponentials. But before we do, we need to talk about the derivative of the exponential. Remember that the derivative, remember written ddx of e to the x, the derivative of e to the x is just a copy-paste scenario. So this is copy-paste. This is what I told you to remember when you take the derivative of an exponential. The difference is in terms of u, d dx of e to the u. Now, if the power is not just an x, which most of the times it's not, when you take the derivative of this, you do a copy-paste, and then you multiply by the derivative of the exponent, which we write as du dx. So in words, this is copy-paste times the derivative of the exponent. Now what you need to remember for today is as we go backwards, what happens is we're going to have a problem that is going to be an integral of e to a power other than x. So what you must do is you must change it to an integral in terms of u. So if you have the integral of e to the u du, as long as these two match, the answer is going to be e to the u plus c. If it's a copy-paste, in order to get the derivative, it's going to be pretty much a copy-paste in order to get the integral or the antiderivative. So this is the key for today. We are going to change every problem into an e to the u. That way we can take the antiderivative of it and then change it back to x's. So you may find a shorter way to do this as we go. That's fine. You're welcome to use that shorter method. So let's start with this example. Our first example is going to be e to the 6x dx. So we want to take the antiderivative of this, or the integral of this. So in order to do this, we have to first identify u. In this case, u, I'm going to write it over here, u is the exponent. 99% of the time. I'm not going to say it is 100% of the time because sometimes it's not. But in most of these problems, u will be the exponent. Okay. So now we do what we did before. What's the derivative of 6x? That derivative is 6, and you must put a dx on the end. All right, now, so what we need to do now is to see, do we have our 6? Well, the answer is no. So we're going to put a 6 inside with the dx. And what do we put out front to balance it out? 1 over 6. So write those things down. Now we change the problem to be in terms of u. 1 over 6, our integral sign. Our 6 and dx become the du. And take a look at what you haven't used yet. E to the 6x. Remember that the 6x is your u, so we just write e to the u. Now, if you look, I'm going to highlight here for just a moment. This is the same thing as this. And since they are now the same, we can integrate and we get our e to the u plus c as it says in the problem. So I'm going to take those highlights off. So we're going to go ahead and integrate. Whoops, I'm still in highlight mode. Let's go back to pen. So this will be 1 over 6 e to the u plus c. But remember, we must change back to x's. 1 over 6 e to the 6x power plus c, and there is your answer. Okay? Next, let's do another problem. In this problem, we're going to have the integral of 1 over 7e to the 4x dx. Notice that everything is on the bottom of the fraction. 7e to the 4x dx. Now, this one's a little tricky because the e is on the bottom. It really needs to be on the top. So you need to think for a minute and you need to change this problem to a different format. We want to bring that e up. So we're going to rewrite it. We're still in blue because we're not changing to u's yet. The 7 stays on the bottom. So this is 1 over 7 e to the what power? Negative 4x dx. Remember that anything that's on the bottom of a fraction, if you move it up, it turns to a negative exponent. Now you're ready to do your u-substitution. So I'm going to say that u is only the exponent, remember, negative 4x. And then du will be negative 4 dx. All right, so now I have 1 over 7. I do not have negative 4. So I am going to put in my negative 4 that I need. And I'm going to put the negative 1 over 4 outside. Now the 1 over 7 is just kind of sitting there. It can move out of the integral as well. So I'm going to move it outside as well, moving this over here, and multiply those two together. Negative 1 over 28 integral. Here's my du. And what's left inside should always be e to the u, and it is in this case, e to the u du. Now we're matching the formula. So now we take the integral of this, which will be, copy and paste, negative 1 over 28 e to the u plus c, and then we change it back to x's. Negative 1 over 28 e to the negative 4x plus c. Be careful that you do not skip this step right here. You need to show that the integral of e to the u is e to the u. And always remember that when you take the integral, you're basically recopying the problem, but what you're doing is you're proving that the integral of e to the u is e to the u. And you're just taking the integral sign and the du off and adding in the plus c. Okay. Finally, let's do the last problem. I keep wanting to ask if you have any questions, but you can't answer me, which is kind of unusual. I'll get used to that. So finally, my last problem is the square root of e to the x dx. All right, now, this one is a little bit different. Okay, if I said that u was x and du is 1, that really doesn't help. You will never have u equal to x. So we need to change the way this one looks. So the first thing I'm going to do is I'm going to write it with an exponent. This is e to the x to the power of 1/2 dx. Okay, I'm actually going to write some things down right now that I do not want you to write down. So just stop, put your pencil down and listen. I'm going to purposely do this the wrong way to show you how you can catch mistakes as you do these problems yourself. Now, right now, this looks like that u should be e to the x. Okay, because the exponent is on the outside. It looks like the first problem that we did at the beginning of the lesson. However, if you do this, du needs to be e to the x dx, and that's not possible because you don't have a second e to the x. This is not a possible way to do this. Anytime you need to put something into an integral, quote unquote, you can only put in numbers. You can never put in x's of any kind, anything with an x attached to it. So this method will not work. So we've got to tackle this problem a different way. So I'm going to go ahead and erase this, and let's think about what we can do. Now, what we can do is we can go ahead and multiply these two exponents together, this one and this one. When you have a power and then a power outside, that creates exponents that are multiplied. So this is really the integral of e to the 1/2 x dx. All right, now we just have a single e to a power like we did before. Now we're ready to do a u-substitution where u is the exponent. So u equals 1/2 x, du equals 1/2 dx. So I need to put a 1/2 in here. It doesn't matter whether you put it in front of the dx or after the dx. Does not matter. But this is a little bit weird because usually I put whole numbers inside my integrals. If I put a 1/2 in there, what do I need to put on the outside? What you need to put is a 2. They have to multiply together to make 1 so that the 1/2 has not really affected the integral at all. So now we're ready to change it to u's. So I have 2 integral Find your du. Here it is. So I bracketed it, put a little bracket around it this way, and just showed that that's du. Is the rest e to the u? Yes, it is. So now we're ready to integrate. I always like to put an equal sign right as I start to integrate, so I remember that that's what I'm doing at this point. Now this is the copy-paste part, 2e to the u plus c, taking off the integral in the du, but now we change it back to x's, 2e to the 1/2 x plus c, and that is the answer to this problem. Okay, the assignment that goes with this lesson, remember the Griffith book is online, so you can get it there if you don't have your own copy. In the Griffith book, it happens to be section 4.2, which is page 111. In the Delta book, if you happen to have a Delta book and brought it home, it is section 20.01, which is on page 349. I would suggest either doing the odds or multiples of 3, like one column, if you're doing the Griffith book. Do at least probably 10 to 12 problems to make sure you've got this. The next thing we will be covering in the next video is the integration of logarithms, going backwards from the derivatives of logs. Have a good day and good luck with this assignment. And also remember that there will be a help room available later this week. I will let you know exactly what day. I will send out an invite for a Google Meet. So if you want to either come and sit and do your homework in the help room for an hour, just while I'm there, and ask questions as you go across them, that's great. Otherwise, you can just pop in and out and ask your questions that way, and I will help you the best I can. Good luck with this, and thank you.